So, hi guys, let's solve the hard problem. 269. It is typical, to be honest. And if you read the problem, you will be like, what this is saying, what this we have to return, what this is all about. Okay. So let me just give you an brief introduction. Okay. Okay. In this, what this question is saying, suppose I have a graph 20341. So let's take this. 2, 0, 3, 4, and 1. Okay. Now they are initialized as -1 weight. Okay. So if I connect them, connect this, connect this. Now the weight is -1, -1, -1, -1. Okay. Now my source is 0. My starting point is 0. So this is my starting point. Okay. And my ending point is 5. Yeah. Right. Destination is 1. Ending point is 1. Okay. So what this question is saying is I have to find the shortest path to reach here. Okay. So first, shortest path to reach here, and that path weight should be equals to target. Okay. This is the true problem. We can find the shortest path with Dijkstra's algorithm. है ना? Okay. Now the thing is we have to find such that the weight should equal to target. And the problem is saying that if a edge is -1, then we can change the weight according to our need. And this weight could lie from 0 to 2 to the power 10. I guess this is the same. 2 to the power, yeah, 2 to 10 to the power 9. My bad. Yeah, this is the way range. Okay, and we can tweak this according to our need. So how can we form this? There is only one path which I'm seeing is if we go like this and reach there, my path is 0, 3, 4, 1. Okay, and the weight lies is -1, -1, and -1. Okay, now my target is 5. So what if I say that if I mark this as 5, this as 0, and this as 0, this become my valid path. So it would be 5, 0, 0. The total path is 5. So in this problem, first we have to find the path, and if there any -1 in there, okay, if there is any negative edge, then first we will do all the on a one node that have extra points and then mark as 0 to others. Okay, so first thing, let's make a graph. Okay, how we solve that? First, we will make a graph where undirect. Second, what we have to do is need a negative graph which will store like if the key is 0, then it will return all the edges which have negative points. It will give 2, 3. Okay, means the starting point is 0, and what are all the negative edges that can go? So it is 3 and 2. And same for 4, it would be like 3 and 1. Okay, This is the two things, graph and negative graph. Okay, so let me just show you. I'm not coding in this because it's a log problem. So this is the number of nodes. Okay, so graph. We are making a simple graph and a negative graph. And this is I, and this is set. Okay, so it would be like if weight is -1, then negative weight node I append this second node. Okay, and I am marking the weight as 1 then. Why I'll tell you later. Means if I'm adding a 0, 2 in the negative graph, then I am making the graph weight as 1. Okay, and then I am adding this in the graph. So graph append same. Okay, or should I just code for you? Yeah, okay, not a problem. So one thing, create a graph. We created a graph. Okay, so this is the thing. A graph with a negative graph set. Okay, now what we have to do. Okay, second thing is why I am marking this as -1 as 1, because if I'm going to use DIJKSTRA, then there is a problem. Like if I using a -1, it will give a shortest and the answer would not be good. So what I'm going to do is hmm, what I'm going to do is like how my algorithm would work actually. So I'm starting from here, okay, and all nodes are 1, yeah, because I converted -1 into 1. And negative graph should look like this: 0, 2, 3, 2, 0, 3. It would be 0, 4, and 4 would be 3, 1, and 1 would be 4. The negative graph would look like this. Okay? Yeah. This is a negative graph, and the graph would simply look like if I'm starting with a 0 node, it would look like 0, 1 means the simple graph. Okay? Or 3 would look like 0, 1, and 4, 1. Okay? This is the thing. So I'm erasing this. Hope you understand the graph also. Okay. Now, what I'm going to do is heap. Now, I will go like which is the shortest path from this position. So there'll be like I can go like this position or this position. Okay. And in the DIJKSTRA, I will have 3 parameters. Okay. One would be negative edge. How many negative edge I have encountered till now. Okay. Second would be the weight of the path I traversed. Okay. And third would be the path that I used to reach here or here. Okay. So it would like how many negative edges I have in, suppose I am here, I started here and I reach this position. Okay. So how many negative edges I encountered? So it would be like 2 because these in the starting were negative, which is stored here. So I will check from this position. So it would be like 2. What is the weight? Current weight 2. The path I followed, it would be like 0, 3, 4. Okay. So this is the register heap thing. Okay. Where edge would be the first parameter, weight would be second, parameter would be third. Okay. Now, the moment I reach here, I will break because I need to find the shortest on the number of edges, not on the weight. Okay. Second thing. Okay. So let me just show you. First, I created a heap where negative edges, weight, and a path which I'm going to follow. So it would be like in the starting, it would be the source. And there's a best path and the best weight. I will tell you later what this is. So what is it? While heap, let's pop the minimum. Okay. Now, now what this path is saying? How I'm saying like it is destination. The moment this will tell me on which node I am. Because if I say the last thing, this will tell me on which node I am. So if I here, this would be the path. If I'm there, it would be 0. So if my current node is equal to destination, I will break. Okay. And there are two conditions. Either we have negative edges or the weight is equal to target. Okay, we can't have both in this because if we have, or we can have both, we don't need it. Either we have some negative edges in the path. Suppose my path is like 0, 3, 4, 1. So in this, how many negative edges I have? So I would say 1, 2, 3. How many weight is it is? So it would be like 3. And path, it is the path. Okay. So moment I see this, I am going to store this path on my best path variable and weight on my best path weight. So I am saving this in my best path and path. Okay. And I'm breaking this. And now how am I traversing the heap? I'm taking the current node from the path. Okay. Now traversing for the graph. Okay. For the nearby node, what is temp node? If the 3 is a node, the temp node would be 0 and 4. And the weight would be 3, 1 and 1. Okay. If I have negative edges, so I will check if negative graph dot node has a temp node. So suppose if I'm at 3 condition and I'm checking for 4, is it the 4 negative or positive? So I will go for path, comma, negative graph is 3. And if 4 is present in the set, then I will say it was the negative. So I am going to plus 1 the negative edges. So in this, I am going to plus 1. The word path, I am adding the path. Okay. Now, if the weight is less than the target, then I'm only pushing the thing. If the weight plus temp weight is greater than the target, I have no use. So push negative edges. How many negative edges I can counter? If plus 1 if it was the weight, total weight, and the path. Okay, the simple heap. Understood? Now, after this heap, there are two conditions. Either we will got the best path or not. If the best path is null, then simply we are returning the null. Okay. Now, the main concept lies here. This was just the basics. Now, what will be my path? 0, 3, 4, 5. 0, 3, 4, 1. Okay, this is my path. And what is my weight? It would be like 1, 2, 3. Weight, weight was 3. Okay, this was my best path, and best. Okay, now in this there could be like this is the link. In this, some could be negative path, some could not be the negative path. Okay, I'm just assuming that some would be negative and some would be. Okay, so what I will do is I'll take a negative set. In this, I will store all the edges from this path which are negative. Okay, suppose in the question like 3 or 4 was positive, like with the value of 2. Okay, now I will check. 0, 3. In the negative graph of 0, is 3 present? I would say yes. So I am going to append 0, 3 and 3, 0 in my negative set. Okay. Now I will check 3. Negative graph of 3 is 4%. I will say no. So I will not appending in the negative set. Now in negative graph of 4, 1%, I will say yes. So I'm going to append 4, 1 and 1, 4. Okay. This is the thing. So this will tell all the edges which have negative in my best path. Okay. Now what I will do is, now I need a result to store. Okay. Now I will traverse the edge parameter which is given in the starting to return all the edges weight. Now the thing is, there are 3 conditions. If the weight in the starting was greater than 0, then I am going to take as it is in my res. Suppose if a node I or j has a value of 10, then I am not able to change this in my result. I have to put this as it is on my result. Okay. Now second thing, what if my weight in the starting was -1? Okay. So in this, I have 2 conditions. Either the edge would be using in the best path and some would not be. Like how will I this edge is -1 in the starting and it is in my best path. So this is one condition. And this is a negative path which is not in my best path. So this is another condition. Okay. This is the condition. Now, if what I give is, suppose my best weight was 5 and my target weight is 8 and I have some negative edges like around 3. Okay. So what are my extra weight that I can use? So extra weight is 8 minus 5. Simple. So 5, 6, 7, 8, 3. So what I will do is I am going to append 3 on my first negative best edge. Like suppose this is my all negative ones in my best path. So what I'm going to do is I'm going to put 3 here. Okay. And in the rest of the them, I am going to put 0. Okay. This is the first condition. And suppose this is a negative weight, which is not in my best part. So what I'm going to use is put this value as 2 into 10 to the power 9. Okay. So this is my second condition. And this is my first condition. Okay. Let me just show you the code. So this was my second part of the DIJKSTRA. And now the extra weight, target weight minus the best path weight. Okay. Now negative path set. Okay. Or the best path, node and next node. So if my path is like this, so this is an edge. This is an edge. This is an edge. So what I am going to do is take I and I plus 1. Okay, and I'm taking this node is the I and next node is the I plus 1. So if next node in negative graph, then I'm going to add this as I want. Okay, this is my second condition. Understood? Now, calculating the result. First condition, if weight is 0 in the edge, I'm simply adding this in the rest. Okay, now if this is condition for the negative weights. If I minus 1 in negative path means in the best path. So I am going to put extra weight plus 1 and make extra weight as 0. Okay, then main product this is in the starting. I have marked them as 1. Okay, so according to that, I have the weight. Okay, so for that, extra weight should be the current value, which is 1 plus extra weight. So it was 1 plus 0. 1 plus 0 like this. Okay, and if this is not in use, then I'm going to make it as 2 in 10 to the power 5. So this is all the code which let me just compress this for you guys. And let's go to the start. Okay, here I am now. Create a graph and the negative graph. Okay, this use a register in which heap would be the negative weight, the weight, and the path which I'm using. Okay, simple register. Okay, and then if the best path I'm getting is 0, then I'm going to return this. Else, my extra weight should be target weight minus the best path weight. I'm creating a negative path set which stored all the edges in the best path which are negative. Okay, so I have updated this. Then I'm doing the result. If weight is 0 in the starting, greater than 0, I'm using edge as it is. If the edge is in my negative path, then I'm going to use extra weight plus 1. Okay, then marking extra weight as 0. So that I can't fill the next edges that I am getting, the extra weight should always be 0. Okay. Else, any edges that are beyond of no use, marking them as the highest weight and entering the result. That's why n is not different. Yes, let's submit this. Mhm. Yeah, submit. Good. Okay, hope you understand this concept. If you do, just give it a like and subscribe. And here's the code you can see. And hope you understand this concept. If you do, just give it a like and subscribe. Well then, see ya. Bye.